15 billion miles from Earth, in the crushing silence of the void, the most distant object humanity has ever created began to scream. It wasn't a distress signal. It wasn't a standard error code. In May 2022, Voyager 1, a machine that has operated flawlessly for 45 years, suddenly started speaking in tongues. The telemetry data streaming back to NASA was impossible. It looked like random junk, chaos, generated by a system that shouldn't be capable of making mistakes. Yet the probe wasn't broken. It hadn't entered safe mode. The signal strength was strong. The heart of the ship was beating, but its mind seemed to have snapped. Engineers at the Jet Propulsion Laboratory were left staring at screens, baffled. Was this the end? Had the harsh radiation of interstellar space finally scrambled the computer's brain? Or was Voyager 1 seeing something out there that our physics simply couldn't explain? To understand why this glitch sent a shiver through the scientific community, you have to understand exactly what is at stake. This isn't just a piece of metal floating in the dark, it is our only eyes in the abyss. And to lose it now, just as it enters the deepest unknown, would be a tragedy for science. When Voyager 1 launched on September 5th, 1977, no one expected it to still be talking to us today. The mission was ambitious but finite, a 5-year tour to explore Jupiter and Saturn. The engineers built it with 1970s technology running on computing power that is a fraction of the key fob you use to unlock your car. The onboard tape recorder, the only way it can store data, has less memory than a low-quality MP3 file. They expected it to last a few years, maybe a decade if they were lucky. They were wrong. Voyager 1 didn't just survive, it evolved into the greatest explorer in history. It exceeded its lifespan by 40 years and counting. It is currently moving at 38,000 miles per hour, so fast that it creates a relativistic time delay. It takes nearly 21 hours for a command from Earth to reach the probe, and another 21 hours to hear back. That means if a crisis happens, the team on Earth is always 2 days in the past. But before the recent trouble began, Voyager sent us a final gift, a warning or perhaps a challenge about the boundary of our home. As Voyager rushed away from the sun, leaving the planets behind, it headed toward the edge of the heliosphere. This is the giant magnetic bubble that the sun blows around us. Think of it as a cocoon. Inside, we are protected by the solar wind. Outside, in the interstellar medium, the galaxy is awash with high-energy cosmic rays and dense plasma clouds from exploded stars. Scientists knew there was a border out there somewhere, a place where the solar wind crashes into the interstellar medium. But they didn't know what it felt like. Voyager found it, and it wasn't a gentle transition. It was described by some as a wall of fire. When the probe hit the heliopause, the specific boundary line between our star's influence and deep space. Its sensors registered something nightmarish. The temperature of the plasma outside our bubble skyrocketed. We aren't talking about a mild increase. The sensors indicated temperatures jumping from typical space cold to ranges between 54,000 and 90,000 degrees Fahrenheit. It sounds impossible. How could a 40-year-old spacecraft made of aluminum, copper, and gold survive a furnace hotter than the surface of the sun? The answer lies in the strange reality of space physics. Temperature measures how fast particles are moving, while heat measures how much energy is transferred. In the vacuum between stars, the plasma is incredibly hot. The particles are vibrating at insane speeds. But the gas is so thin, so sparse, that there are barely any particles to actually touch the spacecraft. It is a wall of fire with no substance. Voyager sailed right through it, unburned, crossing a threshold no human object had ever crossed before. By August 2012, it was official. Voyager 1 had left the solar system. It was in interstellar space. Since then, it has been drifting in a cosmic ocean, measuring the waves of plasma that crash against the outside of our solar system. It found that the magnetic fields out there are surprisingly calm, aligned in parallel sheets, unlike the chaotic turbulence inside our heliosphere. It is quiet out there, deadly, irradiated, but quiet. However, Voyager isn't just a scientific tool. As it drifts further into the dark, it carries a heavy burden. It is preserving the memory of a species that might not exist when the probe finally stops moving. Bolted to the side of the chassis is the famous golden record. This is our message in a bottle. It is a 12-inch gold-plated copper disc containing sounds and images selected to portray the diversity of life and culture on Earth. It holds greetings in 55 languages languages, including Sumerian and Hittite. It carries the music of Bach, Beethoven, Chuck Berry, and the blind blues singer Blind Willie Johnson. It holds the sound of a kiss, a mother comforting a child, the wind, and the surf. But the most haunting part of the record isn't the audio, it's the cover. Etched into the metal is a pulsar map, a star chart using the specific frequencies of dying stars to triangulate the location of Earth in the Milky Way. And because the cover is electroplated with ultra-pure uranium-238, which decays at a very specific rate, any civilization that finds it can analyze the uranium and calculate exactly when the record was made. It is a clock that will remain accurate for billions of years. Long after Earth is swallowed by the sun, Voyager will still be out there, carrying the proof that we were here and that we tried to reach out. This is why the recent signals were so disturbing. We aren't ready to let go of our ambassador yet. So what exactly happened with that glitch? The problem was traced to the AACS, the Attitude and Articulation Control Subsystem. This is the system that keeps the antenna pointed at Earth. Without it, Voyager spins into the dark and we lose contact forever. The engineering team realized that the AACS was working perfectly, but it was routing its data through an onboard computer that had been dead for years. This dead computer was garbling the information, turning clear telemetry into digital gibberish. The probe wasn't broken, it was just confused about who was speaking. It was as if, in the isolation of deep space, Voyager's mind had wandered back to a memory from decades ago. The engineers sent a risky command to reset the system and force the data back to the correct path. It was a Hail Mary pass thrown across billions of miles. It worked. Voyager 1 cleared its throat and began speaking clearly again. But the mystery remains. Why did it switch to the dead computer in the first place? Is there a deeper corruption in the memory, a sign of senility in the machine? Or did a stray cosmic ray flip a single bit in its binary code, triggering a cascade of errors? NASA knows the clock is ticking. The probe is powered by a radioisotope thermoelectric generator, essentially a ball of decaying plutonium. Every year, the generator produces 4 watts less power. The engineers have to make heartbreaking choices. They have already turned off the heaters for several instruments, letting them freeze to death to save power for the transmitter. By 2025, we may have to start turning off the science instruments entirely. By the mid-2030s, Voyager 1 will likely fall silent for the last time. It will become a ghost ship, but its journey will be far from over. In fact, in terms of the galaxy, it hasn't even left the front porch. In about 300 years, the silent probe will reach the inner edge of the Oort cloud, a massive shell of icy debris that surrounds our solar system. The Oort cloud is the true boundary of our system, extending almost halfway to the next star. It is so vast that it will take Voyager 30,000 years just to cross it. 30,000 years. By the time it exits the other side, human civilization may be unrecognizable or gone entirely. In 40,000 years, it will pass within 1.6 light years of the star Gliese 445. But Gliese 445 is moving fast, and Voyager won't stop. It will drift past, continuing its orbit around the center of the Milky Way galaxy. It will circle the galaxy every 225 million years. It is entirely possible that Voyager 1 will outlive Earth itself. It will outlive the mountains, the oceans, and the atmosphere of the planet that built it. It will circle the stars forever, a silent golden monument to the curiosity of a species that once looked up and wondered what was out there. For now, the connection holds. The signal is faint, a whisper across 15 billion miles, but it is there. Voyager is still working. It is still exploring. And as long as it speaks, we are listening. If you want to keep following the incredible stories hidden in the depths of our universe, make sure to like this video and subscribe. The universe is vast, and we have a lot more to explore together.